right? This is Gay-Lussac law of combining volume. You know that it states that when gases react, they do so in volume, which bears a simple number to one another and to the product if gaseous at constant temperature and pressure. That is not important. That it is important to know the law, but what is not important is the application of the law. Now, how do I apply this law? Look at something. You were told in a question, if I give you a question concerning Gay-Lussac law of combining volume, it said 100 centimeter cube of hydrogen as packed with 40 centimeter cube of oxygen at 100 degrees Celsius and 1 atm. The total volume of the residual gas is. For this kind of question, there are steps. The first thing is to write the equation of reaction, which is H2 gas plus O2 gas to give me what? H2O. You know, it has to be balanced, right? Now, I have balanced it. And you understand that from Avogadro's law, that the mole ratio of an equation can be taken as a volume ratio, right? The mole ratio, the number present at the back of a substance in a chemical equation, give you the number of mole of that substance present, right? So I can say 2 mole, 1 mole, 2 mole. But I can also say in terms of volume, this is 2 volume, this is 1 volume, this is 2 volume. Why is it 2 volume? 2 is here. Why is it 1 volume? 1 is here. 2 volume is here. Now, before reaction now, this is how to solve it too. There is before reaction, there is during the course of reaction, and there is afterwards reaction. Please take note. Before reaction, during reaction, and after reaction. All right? What is happening before reaction? What you are giving, right? You are giving, before reaction is what you are giving. You are giving 100 centimeter cube of hydrogen, right? So hydrogen 100 centimeter cube. Oxygen 40 centimeter cube, right? Then before reaction, meaning no product is being formed, right? So the volume of H2O will be what? 0 centimeter cube. Where the main problem is during reaction. How do I get during reaction? This thing can occur in 2 ways. It is in 2 ways. What is the 2 way? First of all, cover the volume of one. Look at the other one. You guessing it? Now, it means according to the relationship between the volume and the volume given, it is 1 volume, right, is equivalent to what? 40 centimeter cube, right? So how many will be 2 volume? 2 volume will be what? 80, right? If 1 is 40, 2 is what? 80. Is that not true? Now, what they gave for hydrogen, is it up to 80? Yes, even more. So the reaction can occur in that way. What is the second way? Look at something. If the reaction cannot occur in that way, you have to cover that for oxygen now as well. So the same thing, it means 2 volume for 100 centimeter cube, right? Meaning 2 volume is 100 centimeter cube. What is 1 volume of oxygen will be what? 50 centimeter cube. What they give for oxygen, is it up to 50? No. So the reaction cannot take place in that way. Then you reverse it. How would the reaction work? When I cover the volume of hydrogen, right? And I take 1 volume of oxygen to be 40 centimeter cube. How many is 2 volume? 80. So here is 40 centimeter cube, right, during the reaction, and for hydrogen it is 80 centimeter what? Cube. Then 2 volume for this one will be what? 80 centimeter what? Cube, because 1 is 40, 2 is what? 80. Then after reaction is now what is left. I was given 100 for hydrogen, right, but I use 80. What is left? 20 centimeter cube. I was given 40 for oxygen, right? And I used the 40. What is left? 0 centimeter cube. I started with nothing. Then I have 80 centimeter cube. What is left is what? 80 centimeter cube. Then you are asked the total volume of residual gas. The volume of residual gas, I mean, what is remaining now is 20 centimeter cube of oxygen, of hydrogen, plus 80 centimeter cube of what? Water, which will give me what? 100 centimeter cube in what? Total. What's it? Now, this is the second example. It is the same idea, right? What is the first step? Write the equation of reaction, right? So this is the first step. H2O gas. Balance it. What is the second step? Get the volume ratio. How do you get the volume ratio from this one, right? So this is 2 volume. This is 1 volume. Please follow the step. This is 2 volume, right? What's the next step? There is always before reaction, right? there is always during reaction, and there is always after reaction. All right. So these are the steps: before reaction, during reaction, and after reaction. All right. How do I get my before reaction? Meaning the volume given to you is the what? Is the volume before the reaction started, right? So I was given 40 centimeter cube of hydrogen. So 40 centimeter for hydrogen cube. Oxygen 160 centimeter cube. Before reaction, no product is being formed, right? So it's 0 centimeter cube. Are you getting it? 40 for hydrogen, 160 for oxygen. Then before reaction, there's no product, so it is 0 centimeter cube. Where the problem is during reaction. And it is the same idea. Just calm down and listen to it. During reaction I can guess it in two ways. The first way is possible, one of the way will be possible and the other way will not be possible, right? So how do I get it? First of all, cover one volume. Okay, I'm covering the volume of hydrogen, meaning I'm taking oxygen as a standard now, right? It means that one volume for oxygen is what? 160 centimeter cube. Is that not true? So 2 volume for hydrogen will be what? 320. Is that not true? If 1 is to 160, 2 is to what? 120. Is that not true? But what they give you for hydrogen, is it up to 320? No. So it means the reaction cannot work that way. I cannot take the 160 for what? Oxygen. What will I do? I will not say, okay, cover that now for oxygen. Are you getting it? So it now means that what? 2 volume is what? 40 centimeter cube now, right? I've covered for oxygen. I'm not seeing oxygen. I'm looking at oxygen. So for hydrogen now, 2 volume is 40 centimeter cube. Yes. How many be 1 volume? 1 volume be what? 20. What they gave me for oxygen, is it up to 20? Yes, and it's even more. So it means the reaction can work by covering the volume of what? Oxygen. Are you guessing it? Making here, taking the 40 centimeter cube of this, right? 1 volume will now be what? 20 centimeter cube. Then 2 volume will be what? 40 centimeter cube. Do you understand? Now for after reaction now, it is now what is left, Abby? I was given 40 for hydrogen. Are you getting it? And I also use what? 40 during the course of reaction. What is left is 0 centimeter cube. I was given 160 for oxygen, but I used what? 20. Then what is left? 140 centimeter cube, right? I started with 0, now I have 40. What is left? 40 centimeter cube. But your question asks you the volume of oxygen left after reaction. The volume of only oxygen left is what? 140 centimeter cube. So my answer becomes 140 centimeter cube.